Hello everyone and welcome to another fantastic edition of SCOM-a-thon. This is the SCOM-a-thon 2021 and today I'm here with Ruud, my colleague.
Thank you. Hey Serge, my name is Ruud van Hooff, Microsoft Customer Engineer. You most likely know us still as Premier Field Engineers. Living in the Netherlands, focusing on monitoring, so SCOM, Azure Monitor, but as well automation. So things like PowerShell, Azure Automation, DevOps, the whole shebang. And I'm a pleasure to actually be hosting this session again together with Serge.
Yeah, I'm looking forward to hosting this session too. As you might or might not know, Serge Zuidinga, also customer engineer, doing the same as Ruud, so focusing on monitoring. I did some automation in the past as well, but nowadays it's System Center Operations Manager, Azure Monitor, of course, and Azure DevOps. And today we're going to focus on Operations Manager, obviously, and we've got a great agenda for you lined up. And our focus is on working with PowerShell and Operations Manager and make it more efficient. So the key word today in our session is efficiency. So let's try to see if we can make it an efficient presentation. The agenda is about measuring is knowing, filtering, what issues you might run into with where object, and hidden gem, we think traversal depth, and then the hash table array. Please know that it's all about Operations Manager and PowerShell, but a lot of code that we use here, or the examples at least, apply to other PowerShell scenarios as well. So it's not just limited to Operations Manager, but you can use it for other products, technologies, code, whatever. We're also on Slack, so if you don't have the opportunity to chat, no problem. We can continue our conversation on Slack. Please note the URL mentioned where you can join. Besides this, the SCOM Cafe is also open, where you can grab a cup of coffee or tea, or maybe something else, and then visit us where we can continue our chat. And then we also have the main site for SCOM-a-thon, where you can find all information about this year's SCOM-a-thon. So let's quickly dive into our PowerShell and Operations Manager stuff. Looking forward to working with you on that. So one of the first things that we say in the Netherlands, or a very known proverb, is meten is weten, and it freely translates to measuring is knowing. So don't guess, but know what the fastest method is. And we've got some wonderful opportunities in PowerShell, which you can use to see if indeed your query is running efficient, or maybe you can find some code you can optimize to make it run faster. So the first command, or the command that you can use, is measure command. We'll dive into that in a couple of slides from now, where Ruud is going to show some great examples. So hopefully you're very familiar with the measure command, where you have the expression parameter to measure the time it takes for your PowerShell command to complete. You can also run a stopwatch. It's maybe more practical where you have multiple lines of code that you want to share, want to measure. Then again, you have to do a little bit more work, because first of all, you have to create your stopwatch. Then you have to start it. In between, you maybe want to record how much time has elapsed, and in the end, you need to stop your stopwatch as well. So it's a little bit more code, but can be very handy as well.
Shall we show something?
Sounds great. You're way ahead of me, so please go ahead.
So let's start with the one with the measure command. We've prepared a lot of these scenarios, because otherwise I'm making always a lot of typos. So this one I actually hadn't prepared. So one of the things with measure command, it's very easy. As Serge already mentioned briefly, we can use the measure command, and we have the parameter expression that actually is required. Not required, it's you don't need to specify, but it's always a good best practice to use the parameter. And here what you can do, you open it with a curly brace and you can do a command like, for example, the get child item. And I'm going to specify here, we're going to do C temp. And we're going to close the curly brace. We're going to run it. Going to run it here with F5. And here you can see, we get some information. We get some information here is about, hey, how many days, hours, minutes, and seconds it actually ran, as well, of course, as milliseconds. But the ones I usually are quite interested in is the one with the total days, total hours, total minutes, total seconds, and total milliseconds. So depending, of course, how long certain things take, you can see here, for example, hey, it took, for example, a total milliseconds of 9 milliseconds. This one will give you all the insights that you need for your script. And what you can do, because you open it with a curly brace, you can actually use multiple lines as well. So just, for example, hey, we're going to run it twice. It's not really something you would usually do, but you can see here that eventually you will have the total duration of those two commands, which is in the full expression you will actually see here. There's only one limitation of measure command, and it's the fact that it won't display the output of the commands. So here you can see, for example, get child item minus path ctemp would usually display all the files and folders in my ctemp folder. Now it actually doesn't display. If you want that, then the stopwatch might be a better solution for you. What you do with a stopwatch is you are going to create a new object based on the system diagnostics.stopwatch. Then what you're going to do is at the moment you want it, so this is something you can actually do on top of your script. And at the moment where you want to calculate how long certain things take, you can use the stopwatch.start method. Then do whatever you need to do. Now, here you can see, for example, that we're using a get child item again. This case only on the C drive. Do we recurse? And we only want to have 10,000 files. So when this one is done, well, we can also use the .elapsed property. And if we use that one, we'll see what at that moment, how much time already has elapsed. Then we can run another command if needed, and eventually we can stop the stopwatch and we can see how long this actually took. So let's do a quick clear screen and run this one. And here what you can see now, I'm gonna wait until it's finished. But this one is the first part that actually happened with the elapsed. So you can see here that it took a total of 1.07 seconds or 1077 milliseconds. And you can see for the second one, it actually took a total of 5 seconds. And this was actually for the retrieving of all registry keys and values in HK local machine software Microsoft. Now, this means here is that the total of those two commands actually took those 5 seconds. So it's not that this part between elapsed and stop only took 5 seconds. No, it was the total duration of the moment that we started until we stopped it that took a total of 5 seconds.
So basically, if I understand you correctly, the get child item only took 3.6 seconds. If my quick calculations are correct.
Yeah, no, it's even more. It's 4 seconds, roughly 4 seconds. But yes, indeed. So you can see that going through the registry is a lot slower than the going through the files.
As well as that I need to work on my mathematics because I'm not very good at subtracting. But hey, that's something different entirely. Not sure whether you remember all those alerts that say that your PowerShell script took way too long to execute and that it was killed by SCOM. Well, this is one way of measuring your PowerShell code and exactly how long it takes. And this allows you to make it mean and lean. So another way to make it mean and lean, or one of the ways to make it mean and lean, is filter on the left and format on the right. And maybe this sounds a bit like kicking in an open door. However, I do, and not sure if you experience the same, Ruud, I do see a lot of commands still throwing all objects through the pipeline where we use a where object to filter.
Definitely, totally agree on that one.
Yeah, and you might notice this with SCOM alerts specifically, where you want to filter out alerts with a specific resolution state, or perhaps with a certain severity. So what we can do, and this is the first hidden gem that Ruud and I would like to share with you. Hope that as far as you haven't noticed the criteria parameter just yet. But what you can do from a SCOM perspective is with the get SCOM alerts, is you just use the criteria parameter to filter on the left and make it much more faster than just get all alerts, push them through the pipeline, and then filter on the right with the where object. So if you take a look at other examples, we have AD user, we have AD computer, AD group, the Active Directory PowerShell commands, where they have a filter parameter where you can use get AD user and then filter and then type in your search query to make to do the filtering on the left, which makes your PowerShell code much more lean and mean. So maybe Ruud, you want to share some PowerShell examples on how we can filter on the left and format on the right to make our PowerShell queries even more efficient?
Yeah, what you actually forgot was the first line with the named parameters. You have a lot of these commands have things like, for example, minus display name, minus name, or any of those situations. A resolution state, of course, is also a well-known parameter for that one. Yeah. Use those ones as well, because compared to doing those into a where object statement makes it even, let's say on the where object side, a whole lot slower than using the designated parameters for those. But of course, they need to help you for the situation you actually want to do. But here we've got a couple of examples, and we're going to dive immediately into, hey, how slow or how fast are these actually? So what we actually have here is we've got a situation where we are going to use a measure command, of course, because that's how we want to go to measure and going to show you why or how quick something these commands are. So let's quickly clear my screen. Now, what we're going to do here is just to give you a bit about the difference in we're going to run these 1,000 times. Why is my environment where we're going to do this is actually pretty small, and you'll see the differences in these, especially how larger the environment is, how bigger the wins is that you actually can get with our suggestions. In small environments, usually you might sometimes even be quicker in certain ways if you're going to do it with a where object, but in the majority, and with smaller, I mean, if you're, let's say, 50 agents or something, but above that or quickly, you will see that there's going to be a difference. But just to actually show a bit, we're going to run it a couple of times, 1,000 times here, just to give you a bit about how actually the difference between those commands are. So the difference here is what we're going to do. We've got a get SCOM class, and we're going to send everything from all classes to a where object statement. And we're going to say, hey, where display name like, and you can see here with the wildcards Windows. The same thing what we can do actually is we can use the parameter name for that one, which is the get SCOM class minus display name. And you can see here star Windows star, the exact same thing. We're going to run those two commands. I'm going to select them and use the F8, or here I'm just going to press the button. Now let's run it, wait until it's finished. Both me and Serge have a lot of patience. This is always the part where you're going to worry, is everything going fine?
It is going fine, but if it takes too long, I'm going to start whistling a song or perhaps sing it even.
Please let it finish quickly. Let it finish quickly. Now here you can see the difference. I already mentioned the total seconds or total milliseconds is usually depending, of course, how long everything takes, the place where you're going to look. And you can see the difference here. So here we've got a total of 24 seconds for the command which was using the where object. And we've got here a total seconds of 3 for the part where we're just going to use display name. And just going to do one thing, just because people are going to say most likely, yeah, but you already probably did this, and now it's being, for example, cached in SQL or anything, or in SCOM, and therefore this one is actually running a lot, would be running a lot quicker now. Just let's try it, just because we can. Don't want to have those debate afterwards in the Q&A. but we'll most likely see it's going to be, yeah, maybe 20 seconds. But most likely it's going to be the 24 seconds again. But in the meantime, while this is running, I can explain already the next one as well. What we have here, we've got a get SCOM alert and we have a where object. And what we're going to do here is we're going to look for every alert with the resolution states 0, meaning is new, and severity equals 2. I'm always confused. I always have to remind myself that 0 is informational, 1 is warning, and 2 is critical. And is monitor alerts equals true. So we have a combination that we want to have all new alerts that have a critical alerts that are originating from a monitor. Now, we're going to do the same thing we can do as well using the get SCOM alert minus criteria. And here we're going to say resolution state equals 0, severity equals 2, and is monitor alert equals true as well, because that's a 1. Now, we're going to run both commands.
Well, Ruud, before you're going to run both commands, the result came back, and as far as I can see, it took exactly the same amount of milliseconds.
Yeah. 24.9 and 24.8. So yes, this is almost actually the same. So there's no caching or anything that makes a difference here. Now, let's clear this one. Gonna run this one, and here you can see is that this one is actually pretty quick. So you can see here, this one ran 124 milliseconds, and here you can see it ran 75 milliseconds. Both of these sounds absolutely like very, very acceptable. But again, my test environment is pretty small. It's completely insignificant if you compare it to most of the customer scenarios. In these ones, you can actually have seconds and seconds in differences, and especially if you're going to do a lot of these queries in your script, where you're going to repeatedly do certain checks. This one can be a huge lifesaver. So yes, it is maybe in this case 75 milliseconds against 124, but it's almost, and I'm going to say almost 50% or 100% difference, depending from which standpoint perspective you're looking. Let's say a difference. It is, in my opinion, still a huge impression, a huge difference. And this is something, it's always good to actually check those differences, check them also repeatedly. So just run them a couple of times. Now you can see there's actually 3856. This is potentially a bit of caching that actually helps it. But just check it a number of times repeatedly and see which one is the quickest. The only way you find out is measuring is knowing. So by testing it.
Definitely.
But this one is potentially a huge lifesaver. If you've got thousands of alerts, this one will make a huge difference.
Definitely, and you can fiddle with the criteria a little bit, make it even more complex to suit your needs without having to push all objects, in this case alerts, through the pipeline and then use a where object for filtering,
Yes.
which definitely makes it a lot faster.
Yeah.
Thanks though for mentioning the named parameters. That's something I forgot indeed, but as you demonstrated with the display name parameter, it's, well, I think 6 to 7 times quicker than using where object. So we see some great examples here how you can make your PowerShell script way more lean and mean, so that you won't hit the 300-second timeout when you run PowerShell scripts from Operations Manager. And then the measure command will definitely help you determine the length of the duration of your entire PowerShell code.
Oh, I'm quickly going ahead. I went to the wrong slide, so that's the right one.
Yeah.
Shall I take over this one, Serge? Oh, you already started sharing as well. You continue with slides.
So, in Hooff, it's 1-0 for me. I accidentally pushed the button, so I didn't mean to.
No worries.
But if you want to do this one, please go ahead.
No, go ahead.
Okay, thank you. I'll try to give it a go. As you noticed during the PowerShell examples that Ruud demonstrated, he was using where object a lot of the time. So where object can be very useful if you don't have any filtering opportunity from any PowerShell command, so that you're forced to use the where object. But then again, it might not yield the results that you expect, and you start to wonder what you're doing wrong. Well, the obvious thing is that you probably made a mistake with the query value. That's something that happens to me a lot with my thick fingers. But then operations manager might do something different entirely than what we would have expected. So it might not just be your query value where you are actually looking for a specific value. Severity is 2, resolution state is 0. It could also be that we're not querying the right property, and that there are perhaps other properties that we should query. So Ruud, I know you have some great PowerShell examples lined up for this one as well, so please share them with us.
So it's a simple one. So what we're going to do here, and this is something that if you're going to start with the combination of PowerShell and SCOM, you're going to run into, and it most likely will cause you like, let's say in half an hour delay. It's like, why the hell is this happening? Hopefully this example will actually prevent that if you have never done it before. But let's show it. So what we have here is we're going to create a variable called var, and we're going to put some data in there, and the data in there will be all SCOM class instances of the Microsoft Windows Computer class. So let's run this one. And what we're going to do now is I'm going to query the var, and we'll see here is if I'm opening var, I've got what is it? 6 machines in there. So like I said, it's a really small environment. And what we're going to do here is I'm going to grab the first item of the array, just because I don't want to see all the others. And we're going to do a select object, and we're going to do star. Now, these are all the properties of this specific class instance. And what I want to do is I want to know is what are all of the class instances that actually originate in this specific OU. Now you can see here the property here is called Microsoft.Windows Computer between the square braces .organizational unit. So what am I going to do? I am going to run this specific query. And you can see here we're doing a var and then a pipeline to where object. We're going to say the $_ and then you can see here we've got the single quote. We got the name of the property with Microsoft Windows Computer, and then we got the .organization unit, and we can say minus equal OU is servers, comma DC is RHnet, comma DC is local, because hey, specified there, is it? Now, if we're going to run this, and I'm going to run it here. Did I click it? No, I didn't click it. See, no results. So why is this actually? Now, let's show it a little bit more in more detail. Let me quickly copy this one, because what actually happens is that this property has subproperties. So, for example, if I'm going to do this and I'm going to just display it, you can see already here is that we have subproperties called property access rights, parent, type, value, ID, management group, and management group ID. And you can see here that the actual value is in value. So what we can do here is I can actually get value. And here now finally we have the value. So simple thing now, instead of using the .organization unit and then the single quote, we actually are using followed by the .value. Now, if I can actually select it the right way. Now we finally actually have all these machines. All of my machines reside in the same OU except for the domain controller, but you can see here that now you're finally getting the result that you actually need. Anything to add here, Serge?
No, not at all. I was trying to find a goof in your code, but it actually makes sense. So well cool. Done. Yeah.
Next one up is traversal depth, and
another hidden gem, I think.
Definitely traversal depth is the one that is a hidden gem. So One thing traversal depth is for is it's a method that this is a real hidden gem, because you don't find that much information about it online. If you never actually search for it, there are different solutions for it, and it's more or less to give you a really efficient way retrieving alerts, for example, for a member of a specific group. And this is a situation that happens quite often, because there could be situations where specifically for a group, you want to know what kind of alerts they actually have originated with a specific criteria there. Now, one of the questions, of course, is why do you want to use this? Now, let's just grab first the solution that is more known. So we've got a situation here, and the situation is we want to have all alerts for the All Windows Computers group. What can you do for that? One thing you can do, and this is already one of the efficient methods, is you can use a method called getRelatedMonitoringObjects. And you can see here we can specify a specific parameter here, a specific value, which is called recursive. And what we're going to do here is we are going to get all instances that are related to the group we're going to specify here. So what do we have here? We specify a group name called All Windows Computers, just something that you have. Could be as well, for example, a group of a specific department, for example, a DBA or a Windows team or any other application team. And here you can say, okay, we are going to create a variable called group, and we're going to say, give me with the get SCOM group minus display name, the group name. So far, we only have the group object in there. But now we're going to say, okay, give me all of the related monitoring objects. So of all members of those group, it will get all of these instances. So this is already something really useful, this method, to actually get all the instances that are related to the specific, to those group members. Now, when we have this, we can use actually the getSCOM alert minus instance, and we're doing a class instance, and we're going to do a where object on here, for where we're going to say a resolution state not equals 255. So now what we have is actually a command that as a result will give us all alerts that are still in an active state, so not in a closed state, for all of those class instances. So far, so good. This still sounds like a really effective situation. However, there is something which is actually a bit better. There are even solutions you can find on the internet where people are doing is they're doing the group, then they're going to do the class instances on it, and then they're going to do it a number of times eventually to get all items. This is, of course, a really inefficient method. This one is already a bit better, but luckily we've got traversal depth. And here we have it. The example is the Microsoft.enterprisemanager.common.traversal depth. And here we can specify the recursive. Now, what are we going to do here? These are the steps actually involved to do this. One thing what we're going to do first, similar to the other example, is we need to get the group that we actually need to do this for. So group name, All Windows Computers, similar to what we had in the previous one. And we are going to store that one in a variable called group. And we're going to get, of course, the information directly from SCOM using the get SCOM group minus display name. Then we are going to specify optional criteria. Now, one thing that we're going to use here is an example here with a time raised. And we're going to say, hey, give me the ones which actually have been raised in the last 15 minutes and a resolution state that is not closed. So I'm more or less saying, okay, give me all alerts that have been raised in the past 15 minutes and that are still in an active state. Now, other criteria that you can do, for example, are, hey, criteria resolution is not equals 255, meaning again is all active alerts. But also, for example, is monitor alert equals 1, so it's a monitor alert, and resolution state equals 0, meaning is every new alert that is raised from a monitor. And then we can do is we can say, okay, the criteria group, we need to put this in a specific object. And here you can see we're using the Microsoft Enterprise Management.monitoring alert criteria for it. And we're using as an input the criteria that we've specified. This part, by the way, is still optional. These lines, because you don't need to specify the criteria. So theoretically, these lines here don't actually need to be specified if you want to get all alerts. But then we're finally going to use a traversal depth. The only thing what we're going to do here is we are going to create the object based on the code here. And If we don't actually have any criteria, then we can use the method specified here that is now being commented out, is the $group.get monitoring alerts, and then we're going to use traversal depth. If we do actually have criteria, which most likely in most situations you actually will have, we're going to use a .group.get monitoring alerts, and then we're doing the criteria group and the traversal depth. So there it actually accepts two values for this specific method. Now, show this. Now we've got the same example actually here. What we have here is the group name. We've got the all Windows computers, the SCOM group. So more or less everything is here. And let's run this without even selecting anything. And here we can see now that we have a really quick result actually of this command. So this one especially, and this one is really difficult to show now because my environment is so small, but I've had situations here that scripts went from, let's say, 20 seconds run till that they ran actually within seconds. These ones can actually have a huge difference. So traversal depth, like I said before, you can't really find much about it on the internet, but if you actually know about it, you're going to use this in your script. It can be a big win into your script regarding efficiency. Again, test it, and then you'll see what the differences are.
And now that you know the measure command, maybe you already knew it, or the stopwatch, you can measure it exactly, and you can see how much minutes, hours, maybe even you can save.
Oh, one thing, of course, let me quickly run the other example, of course, as well, because I haven't showed that. So let's do the exact same difference, of course, because, hey, otherwise, what we'll do is we'll sort of like cheat. Let's put a measure command here, minus expression. Won't be lined out really nicely, but hey, let's run this one. Let's see how long this one will take. Now, this one takes now about 1400 milliseconds, and then we're going to traversal. Let's change the criteria because we want to exactly have the same one. Here we have every alert which is not 255. So let's do the same thing, which is similar to that one. We'll get that one out, and we'll run this one. Save that one. Oh, I forgot to put the measure command, of course, in there.
Yeah. So it's an equal score on good now. Yeah, I'm counting. I'm working on my mathematics.
Good. You should be.
You.
Let's quickly run this one, save it. And here you can see that this is a huge difference. So we went back, actually, we had 1400 milliseconds on one, we got 36 milliseconds here. Just to be sure, I'm going to run this one again. Might be wrecking my story, but here you can already see it. We're going from 36 milliseconds. Yes, this one actually improved as well a bit because it went down in time about half of it, but we are still in a difference between 36 milliseconds and going into 749 milliseconds, which is, in my opinion, yes, in a lifetime, now just probably won't see, you won't see the difference. But there are situations where you're going to do repeatedly those checks. So let's say you want to check for a certain number of groups, these alerts. This might be already, let's say you're going to do this 10, maybe even 100 times in your script. And then you'll have these differences. That's a big difference. So definitely don't, how to say it properly, in a way is that don't ignore these differences. Yes, it might still be 749 milliseconds, which is quicker than you almost can say it, but still it's a difference between 36 milliseconds and 749. It's mind-blowing.
Like you mentioned, Ruud, in some customer environments, it might make a difference of minutes. And imagine you have a critical alert that you need to act upon immediately, and it's sent through one of the many connectors where you use PowerShell. It can make a huge difference.
Oh yeah.
You might be minutes earlier in receiving the alert and acting on it, and then that you have to wait.
Anything to add to this one? don't think?
No. You once again you did a wonderful job. So nothing to add that I already haven't said. So thanks, and allow me to take over from you, and spend a little time on hash tables and arrays, because storing data is all the same, right? Or perhaps not. Well, let's have a look at an array. I think everyone has already worked with an array. It's very easily to create and work with arrays, searching through arrays. So you can do a $services is get service, and ta-da, that's your first array where you can quickly search through. It's very easy to create an array and work with it. And then if you take a look at the definition, it's a data structure that is designed to store a collection of items. And those items can be of the same type, but can also be of different types. If you work with an array, it's like I mentioned, very easy to create one, to search through one. You can do a $service is get service, and then $service pipeline where object equals. Or perhaps not, because that's not the most efficient way. But I think we all recognize how we can search through arrays that way. So working with arrays has some downsides as well. For those of you that use getMember to see what methods and what properties are available on any type of object, including arrays, might notice that when you do a getMember on a array object, you will see that it has a method called add and it has a method called remove. So sounds like fun, but I'm going to spoil Ruud's examples a little bit. Those won't work. So it's maybe a little misleading in a way, but those two methods just don't work.
Should I share my screen?
Yeah, sure. Maybe a good idea. I know you've got some examples lined up for us.
Yes, so we're going to quickly run through how you can actually do things like creation of an array, search through it. We'll just do it quickly because I guess most of you actually work with this. It's more or less sort of like a step up to what we want to do with hash tables, because these are a little less known in certain cases. But here, do the quick one. So here we can see we've got alerts, and we're going to use the add and then the parentheses or round braces, how you want to call it. This is the creation of an empty array. But you can also just create an array by doing a get SCOM alert, for example, and save that to a variable. And that's already the creation of an array as well. Same thing for things like get process, get service. This can actually be an array. One thing to be said here, it's only going to be an array if there's going to be multiple instances of it. And if it's going to be one instance, then it's just going to be one an object with one item in there. But here we've got other things as well. Hey, we want to search through it. We can use the where object. Now, we already touched that one a couple of times here. One of the things as well, which arrays are quite handy for, is we can actually access the individual items of the array by using the one with the square braces here, and then put an index number there. Almost everything in IT, if you're talking about items in arrays, starts with a 0. So the first item of the array is a 0. If we actually want to have the fifth item of the array, we're actually going to use it with 4. But you can also use it with the negative one, because the -1 actually is the last item in the array. So it's quite handy if you want to have the first and last item in the array. You can use 0 and -1. Now, adding items to array, for example, we can do an alerts, and then that we can just here start with an empty array. Let's do this one. So let's start it, select it. Now here we've got now create an empty array. We can see in alerts there's nothing in there. What we can do as well is we can do a get type on it, for example, and we can see here it's an object for all the base type system.array, but there's nothing in there. But now what we can do, for example, is we can use the plus is, and if we're going to just do it to this one, what we'll see now is that we'll most likely have anything in there. Hey, you see I had the all management service resource pool available, and these are now all of the closed alerts. Why? Because we use the resolution state minus with the 255, which are all closed alerts. Now we can do as well, do the next one, and you'll see that if I now do alerts, you'll see I have much more there, but there will only be of the state closed and new. Anything like resolved won't be in there. Now, one thing, and Serge already spoiled it a bit, is there is a method called .add, and it's definitely even on the array as well. But if we're going to do that, and we're going to start with an empty array, and I'm going to select one, you'll see, hey, collection was of a fixed state, of a fixed size. This is because this is a method you'll use with hash tables. Now, here, one thing that an array that actually doesn't allow you directly is removing items of an array. The only thing what you can do is more or less search for all objects that are not of that specific type, and then save that one. Or you can say, for example, using a for each object, if it is of a specific one, display it, and then save the output as well in a new variable. That's the only way that you can do. Then we've got the things like sort object to sort it. And these are all ways of just sorting your objects and everything, what's possible to display it in a better way, find the right objects you want.
Yeah.
So this was in a quick run the part about arrays. Shall I take one over, or are you going to continue? You're already taking over, I see. Good.
Apologies.
No worries.
But if you do all the talking, I'm just going to click on the next slide.
Oh, I thought you...
I was just waiting to see your reaction. So no, apologies, but I really love hash tables. So I really like to. I also love talking, by the way. So I really like to take over. So nothing to do with you. It's all me. Apologies. But then hash tables. So hash tables. Also a data structure, but this is known as a dictionary or associative array, where we have a compact data structure that stores one or more key value pairs, and that's very important to notice. And I'm sure Ruud is going to elaborate a little bit more on that, but key value pairs is very important to notice. So now that you know the definition of a hash table, let me quickly allow to talk about it a little bit more. Don't want to take up all Ruud's time because he's got another example lined up. But we have the ability to use a key value pair, which will definitely increase our performance. So if you're ever going to store data, large amounts of data in a variable, you might want to consider using a hash table. It's similar, creating a hash table is similar as to what we saw with arrays, but instead of parentheses, we're going to use curly braces. And working with hash tables will be a lot more efficient. And not only because it's quicker to search, we can now also easily use the add and remove method. And as you saw in Ruud's demo, that doesn't work for arrays. So Ruud, maybe you want to share some cool PowerShell code for hash tables?
Yes, let me share my screen again.
And add, obviously, what I forgot to mention.
Oh yeah, no, you didn't forget that much, but here we can see is, so one of the things is that with a hash table is quite important. We always need a key value pair. So one of the things is really important is that we need to make sure that there's always going to be a unique value in the key value pair. So it means in the key. But let's dive into this one first. What we can see here, Serge already said it, is that the creation of a hash table, an empty hash table, is the only difference is between that is, I'll make it a little bit bigger, is we're using the curly brace here. So this one now is an alerts, and we're going to do a get type. And you can see here now is that this one is now a hash table. So it's different compared to the other one that we had. And adding to a hash table is also different because we're not going to use, like in the other examples, like $var is get service. No, we need to actually add something to a hash table. So what we do here is with a get SCOM alert, and we're going to do in the pipeline for each object, and we're going to say alert.add. And here we're going to say, okay, we want to have, because we need to have a unique value there as the key. You can see this one is a key and that one will be the value. What we need to do there is actually we need to find the sort of the unique value in there. Now, keep in mind certain situations, for example, with an alert, the ID of the alert is always going to be unique. But think about things like a fully qualified domain name of an agent. That could be, in most cases, that's going to be unique as well. Those kind of things can be sort of like the unique value that we need. Think about files, for example. The full path of a file on a server is also something that's going to be can be unique. So here what we're going to do is, this is the way of actually adding these items to an to the hash table. So if we're now going to do alerts, you can see here we have a slightly different structure. We've got now name and value, and in the ID here is now specified in the name and value. It does only look like we only got the name of the alert, but what we actually got in there is the full object of the alert. Now another example, what we can do here as well, I'm going to show you. Just going to run it first. You can see here we're going to create a hash table called instances, and we're going to grab all instances of a class. And you can see here from the Microsoft Windows Computer class, and we're going to add, and we're going to use a display name for that one as the key, and we're going to use a full object as the contents of the value. Now, then the differences, here we're going to start just for now an empty hash table. We've got now hash, and what we can do, for example, is we are going to add items in here, and we're going to say, okay, I want to have the all services on my machine. And here you can see we're doing a hash.add, and we're going to use the name. Now, services always are unique on a system, so therefore we can use the name of it. We're going to dump the whole object in the value. Now, one thing what we can't actually do on a hash table is just use the where object. You can see we have nothing here. Despite knowing that we definitely have a service called spooler on there. So let's quickly check that just to be sure. In case you don't believe me, we definitely have that. But a where object just doesn't work on a hash table. If you do want to make it work, you can use the get enumerator method. The only thing what you need to keep in mind is that then you're making it you make it inefficient. But yes, this is still possible. You can see now we actually have the result of this one. We can also do is check to determine if the spooler is definitely there. So we can say here contains key method with the spooler, and they say yes, there is actually a key called spooler. So we have some information there. And now actually to get the information out of it, we can use two methods. One we can use is it based on more like the property method, from a variable, or you can use it with the index in the you've seen the index in the array. Here it's going to be the index of the hash table. So both methods, I'm just going to run them both, will actually have the same result. It's the full object that we've put in there. One thing that doesn't work, what we can't do is, as long as there is no item there called 0, it won't display this one. So this one won't get you the first item of the hash table. That just doesn't work. Now, one thing we can do is here, I'm just going to display it quickly. We have now, this is the full all services in my hash table. And one thing I can do is I can just remove individual items in here. So now this one actually doesn't contain any spooler value in there anymore. So if I now, for example, run this one, what you'll see is don't get any information in there anymore. Now, same thing is that sorting, similar as to what we saw with the get with the where object, doesn't work. If you want to do that just on screen, there's a get enumerator, and you can do the sort object. Then you will display it on screen. Because Serge, you already have a good explanation for this. Why this doesn't work?
Apologies. What?
The one with the get enumerator. Why the sorting? Why doesn't work?
You got me there.
Oh, no, it's more or less, is that a hash table? And that's one thing that we haven't told you actually yet, is that a hash table, if you're going to add items to a hash table, they won't actually be added in the order that you did. There's a word for it, which we always have both really difficult to pronounce. Yeah, I'm going to do it. It's intricately sorted. So
Intrinquisitely sorted or something.
I
was trying to forget about the whole subject anyway, but you brought it up anyway. Intrinsically.
I don't know. Let's don't dive in because we're already sort of running out of time. But yes, so what it actually is that if we are going to add items to a hash table, and one thing we can quickly do is I'm going to create a new hash table. I'm going to do a hash, and I'm going to say add, and I'm going to add 1 with a value also 1. Now I'm going to do 2, and we're going to give it a value 2. Oh, 3. Error, but doesn't really matter too much. Let's do this 3 as well. If I'm now going to display hash, you'll see here that we actually, here we got 3, 2, 1. It sounds like it's actually from the other way around, but you will see quite often as well that 2 could be on top because a hash table is sorted in a way that it's the quickest way to retrieve those information.
Yeah.
You have actually an order dictionary that you can use, which is performance-wise, I would say almost exactly the same. There might be a minor difference, but
Right.
I've never seen it actually in a difference in milliseconds. But then you can actually have a situation where you're going to add items to it. It will actually be added to the array in the exact same order. And then we will see just 1, 2, and 3 with the name.
Yeah, that's why you use ordered between square brackets when defining your hash table, and using ordered within squared brackets will make it a ordered dictionary. Definitely. So you did get me to say the word. I hope I pronounced it correctly, because like you said, it's very difficult to pronounce. So hopefully you all understand what we mean. So when do you want to use arrays or hash tables? Well, it depends entirely. It's all in the name of efficiency, like the slide mentions, but keep in mind your data set. So if you just want to quickly have some information and you're not going to do very intensive operations with the information you just got, you might want to work with an array. But hash tables tend to be far more efficient, especially when you want to retrieve information. And it's a little bit easier to store whole objects as a value for a specific key compared to an array. It really depends actually on what you want to work with when it comes to SCOM data or Active Directory data, maybe from SQL, large data sets. One of the other great advantages of a hash table is that you easily can use it for draining. So as soon as you process the value for a specific key, you can easily remove it until your hash table doesn't contain any items anymore, and then you're done. So one of the examples that Ruud has tested is where we actually use files from the program data, where you can work with an array versus a hash table, and you can see that the hash table only needs 3 seconds, where an array takes a total of 18 minutes. So I think that's a very good example why you might want to use hash tables on a large data set. There's also a very nice article Ruud came up with.
Yeah, this is an article from Ars Technica from, I think it's, yeah, I see here, it's the 1st of March. And there was an issue that a lot of people that are playing GTA Online suffered from, is that it took a long time always to load. And there was a guy, was a hacker that actually got bored of it as well, and looked into the code and found out that there was actually a files being loaded with a 10 megabyte JSON file, which had a total of 63,000 entries, and all of these entries would be processed. What he actually did is he changed it in a way to actually use a hash table for it instead of just a normal sort of array. and actually got to a 25% load time reduction of GTA Online. As far as I know, I think I'm not sure if actually true, but apparently he's also been offered a job at is it Rockstar, the creator of GTA. But here you can see this is a huge difference in the in a real life example. But of course, in the other example that Serge gave, with the 3 seconds or 18 minutes, that's a huge difference. And just going to show you some examples as well, what we have on the SCOM site and how you can actually sort of use this. So what are we going to do? Because we want to show you sort of difference, what this difference actually could be. There's only one problem. I've already told you is that hash tables are really an efficient way if you have large data sets. And again, I've got a small SCOM environment, so it's going to be sort of an issue to show you the big differences in it. We're going to try to mimic it a bit. So what we're going to do here is we're going to get all agents from my SCOM environment. Next step we're going to do is we are going to grab, 100,000 files from my C drive. Let's just quickly grab a path in there because I don't see a path. It doesn't really matter. We're now in a location where we can do that. And what we're going to do is we're going to first fill the array. And we're going to fill the array with the files that we have, just to have 100,000 items in there. And we're going to add the items from the SCOM agent in there, just to make sure we've got a large array. Now, then what we're going to do is we have a situation which is really applicable to situations that you can actually face in SCOM as well. The problem is in SCOM is that we have multiple classes which are more or less doing the same, but the information is spread on different sites. For example, we've got agents on one side and we've got the Windows computer class on the other side. The agents contain, for example, information about failover management servers and primary management server, but it doesn't contain any information about the OU where they're located. So what we're going to do in this example here is we're going to create more or less a new object, and that object contains the display name, the action account, and proxy enabled. This information comes all from the agent, but what we want to do is we want to get the organizational unit from the Windows computer class. Now, similar, what we're going to do as well is we're going to do the same thing with the hash. And here you can see we're doing the exact same thing. What we'll use for the hash is the display name as the key value, because that's one where we actually find those computers. We're going to do the exact same thing as well on the hash, only use the hash statements. When we're running this script, in the end, we'll get as well the differences between it. So let's kick it off. Now, you can see this is all pretty quick. What we can see here is the differences. So first is that we're going to do the fill of the array. And you can see here that took a total of 53 milliseconds. The total of the whole array query, so making that whole object, took only 467 milliseconds. It's pretty quick. Here you can see if we're going to fill the hash, and there is one thing is that filling of the array of is most likely quicker than the filling of the hash. You can see here that the difference between those is between 53 milliseconds and 167 milliseconds. But then what we'll see actually is that one was so freaking quick. There's even it's below a millisecond. That now I'm in doubt if it actually works. But yes, let's quickly run it again. I see so much quick times, but yes, again, it's lightning fast this time. You can see here that the difference in there is so enormous, at least in the hash, that if you're going to do these multiple times, and especially if you are going to have, for example, 1,000 agents, you'll save this time, because now I only got 6 agents. 5 actually, because some of these are actually SCOM management servers. So I've got 4 agents. So if you actually compare this, if you're going to run this against 1,000 machines, for example, which is for SCOM still a relatively small environment or mid-sized environment, the difference is already huge, because you're going to run this, for example, 250 times. Or let's say in size, it's going to be 250 times bigger than what we're doing here. And then these differences will actually become a whole lot bigger. So definitely check into your hash tables if you're going to do certain, like those frequent lookups. Hash tables could be a major lifesaver here. In practical situations, you saw, for example, the example we had with the files that took 3 seconds, which the other solution with the array took 18 minutes. I was able actually to reduce scripts from 20 minutes to a number of seconds with combination of hash tables, especially in combination with SCOM. Hash tables could be a huge lifesaver.
Yeah, definitely. Totally agree. I sincerely hope that you all can experience the benefits from this. Not sure whether if there are any questions, but we do have a live Q&A. So if you have any questions, this would be the moment. So while you're typing them, or perhaps you have a mic and want to share them. Okay, thanks for all the good questions. Thank you for attending. I'm sure I speak on behalf of Ruud as well, that it was a pleasure for us to show you this PowerShell efficiency crash course, not only for System Center Operations Manager, but perhaps for other tasks where you use PowerShell as well. I hope you enjoyed it. I hope you'll enjoy the rest of the SCOM-a-thon. Looking forward to seeing you the next year. But first, head over to the cafe if you still have some questions or just like to chat about PowerShell Operations Manager. I'm sure a lot of other presenters will be there as well. So see you at the cafe. If not, I'll hopefully see you at next SCOM-a-thon.
Hey, thank you.